Next, please. Okay. Okay. Okay, so please join in with, can you join on Google Meeting? Okay, can you join on Google Meeting? And we'll start, yeah, so please load your Google Meeting and we'll join with that. Thank you very much. We okay? Google Meeting? Good, okay. I was sharing my screen. Huh? See you. What? Huh? Why is the link not working? Okay, hang on. Okay, just a sec. What's the Google Meeting? Google Meeting. Okay. Okay. And which screen am I sharing? Okay. Which screen am I presenting? Which screen am I presenting? Okay, good. First one. Good. Okay. Okay, so for today's class, we're going to continue working on arrays and trying to understand moving the program up to an arrays. And admit 3 guests, okay. Admit all. Okay. Okay, so we'll be using Google Meeting today. So starting off, what I want, again, we'd like you to download, going down to arrays, please download this guy, GLoop, okay? GLoop, because that's the one we're going to modify together. So just download this code first, okay? So first thing I want, okay. Okay, so download gloop.c. Oops, I don't want that over there. Hello, Melody. Hello, Chloe. Okay. So back to where we were. Okay. All right, so it's this guy we're downloading, gloop.c. And while you're there, you might as well download oloop.c as well. Okay, download both these guys, oloop, gloop, and oloop. Okay, and we'll just save them on your computer because we'll be working with both those today, gloop and oloop. Okay, so download them both. So let's get Notepad. Okay. Okay. Okay, so you're going to basically download gloop, okay. Store it. File, save as. Okay, I'll just g.c. Okay, and I also want you to download the oloop.c. for the day's class. File save as, I guess, O.c. Okay. So okay, we download those two programs, and I'll open my G.c again. Okay, so you've downloaded hopefully gloop.c and oloop.c. Okay. So you guys make sure everybody's downloaded, okay, guys? Everyone's downloaded? Sabrina? Is everybody downloaded? Johnny? Can we get started? Okay. Okay, anybody? Okay. This one, and say it's a notepad. Okay. Download, okay? Oh, don't say okay. Okay, so yeah, so my okay. Sabrina, is everybody okay on that side? Okay. Okay. Okay, I think everybody is sort of okay. All right. So let's first of all we'll look at this code. I'm going to talk about it first of all, going through it. So you have your code up. Our G loop. You can see we have our functions. All right. making use of arrays. So this program does not make use of arrays. We will now make use of arrays. There's our program that you just uploaded. It works well. It stores everything. But what things can we do to make it maybe? Okay. Hi guys, question over there? Ladies, question? No question over there? Okay. All right. So this code works, and it solves the problem we were trying to solve at the beginning. So it's okay. It has a few minor limitations. You have to run the program twice. Input, calc, and output are together, and you can't format as one table. So you can't really format your output very nicely. Okay, one solution is to use arrays, which would allow a single run of the program and allows us to separate input, calc, and output, and format output as one table. So what do I mean by this? Okay, let's go back to the UML. This is the UML of our program, right? Read H1 and T1, read H2 and T2. If there's more data, we continue on. We take the average, we calculate velocity, we then save velocity and time. We then put the value in H2 and H1, the value into T1, 2 into T1. We read a new value of H2 and T2, and we check. If T2 is greater than 0, we'll just keep going. Okay? And then, so that would allow us to calculate the velocity. Then we ran the program again, this time with the velocity as being the input and we would there calculate the acceleration. All right, so now it's our new T1, T2. It's the same program though, right? We were able to run the program twice. Okay, you guys should be wandering around, okay? Okay, making sure that people are lost, helping them. Okay, if you have questions, please answer, yeah. Okay, all right, so the problems here, okay, so this is the way the code looks now. We did input, we did calculations, we did output, we did more calculation, we did input, we did more calculations, we did output, more calculations, input, more calculations, output, program finished once. Then we started again. More input, more calculations, saving, more calculations, more input, calculations, save, calculations, input, calculations, save. So we're making input all over the place. We're not just in one spot. So if we use arrays, we can rechange this. Let's do all the input together, and we'll only have to run the program once. So this we can then switch our UML. There would be our new UML. All our input is here. We make a first loop, and we store all the input into an array. We then do all the calculations of velocity. Okay? We then take the velocity calculations and do all the calculations for acceleration. And after that, we complete the output. Okay, so now so you can see the different structure. Input, calculation, output. Previously it was input, calculation, output, input, calculation, output. Bijao, not as pretty. Now we have it, this will allow us to make it nice and smooth and easy. Okay? We understand? Okay. Okay, Ryan, do you understand what's going on? No, of course, yeah. Okay, try to understand what's going on. You haven't even got a meeting on it, I don't think. Sheesh. Okay, all right. Okay, let's continue. So, how are we going to start to adapt our program to do that? So, that's what we're going to do together. This is the program. We want to adapt it to using this sort of structure. So, if our UML is wrong, it's very hard to write the program. Okay, so that's an important thing to note. UML must be done correctly. Okay, so here's my coding. I'll start here. You guys can also do the same on yours. Start to make the code changes. Okay, first of all, let's look to see what variables we need. We need a new two integers. Okay, I need a I. So I'm going to need a long I. Right here I got long I and a long N data. Okay, and I'm going to need some arrays. Okay, my first array is going to be H and a T to go with it. So double. So I'll have H and I don't know, we have to decide how big we want it to be. So let's just, first of all, define a number that's going to be too big, like M100, okay? Then I can change this later. H100, T100. Okay, so now I've got H and T. What other variables am I going to need? According to my UML, I'm going to have something to store my velocities. So that means I got to store all my before I didn't need to do that. Now I do. Velocity. Let's have 100 for those. Oh, I should use M. Sorry, my mistake. Because I declared an M, so I might as well use I should use the M. And I got to have a T for each of those. According to right here, I have another T at each of these velocity points. And what else do I need? Acceleration. So a whole bunch of accelerations. And the time at each of these acceleration points. Okay. That looks like I pretty well completed all my new variables that I need. I don't see anything else here that I would need. That's got H, TH, V, TV, A, and TA. Okay, so so let's get our containers created now. Okay. I'll give you a few minutes to work on that. Make sure you have your containers all created. Okay. They got kicked out, or they were too late? They shouldn't have got kicked out. They probably didn't get admitted. Okay, late. Okay, got it. Okay, admit 2 more students. Okay. Did I? Well, admit all. Okay, good. Hello, Gary. Welcome. Okay. Actually, I should make it. Maybe I can do it this way, more easier. Okay, sorry, that should make it more simpler. Okay. Okay. I don't want to do that. No, don't do that. Ah. Shoot. That's not what I wanted to do. There we go. Back to where we want. Okay. Okay. Are we pretty well, everybody? Is everybody okay, Johnny? Okay. Let's now look at our UML again. First thing in our UML is I is initialized as -1. Okay, so I have to initialize I as -1. I equals -1. Okay, so I've initialized I as -1 as in my first step. Okay, now I can look at this loop. Look at this loop that we have. The testing is at the end. Testing at the end is what type of loop? It's a dual while loop. Okay, so we need to have so we're entering a loop right here. So it's going to be entering with a do, and it's going to be there's going to be a while. So it's a do while loop. Okay, so let's see, and we can put that at the end there. So the do while. So what are we doing? The first thing is we're adding a 1 to I. Okay, so at this point I is going to be equal to 0, right? Because of how, maybe I need a little more space to go show that. Okay, so we got the do while loop and we're trying to, okay, so I plus plus, I is equal to -1, so now I is equal to 0. And we're now going to read HI and TI. Okay, so I got to get my read guy. I need this guy. And I'll stick him in here. So I'm going to be getting, but not, I called it H now, so TH, not 1 anymore, but I. Not T1 anymore, but TI. Okay. And okay, so I'm reading, and I've got to keep reading until when? More data. Ti greater than 0. Well, T brackets I greater than 0. Okay, or greater than some small number. I think we said before it should be greater than or equal to minus EPS, right? So let's just so it's this while statement we want. Greater than or equal to minus EPS, so we'll just move it up. Okay, so my input part is now finished. Okay, so I've got my input section done. Let's look at what we've got so far in our code. Integer main void, long I, all the input is now completed. And we can start next step where we do the velocity. If there's any questions you have on this, ask the TA or ask me. We'll try to help you make sure you understand this up to here. Okay? These guys okay over here? You guys okay up here? You're okay? Okay. So, okay, let's now start to calculate the velocity part. So remember the velocity, we already have the formula down further. But now we're going to be moving it into a loop. So first thing we need to do is n data equals I. So n data equals I. Okay, and I equals 0. Okay, the two things we want to, and this is going to be a for loop. Oh, it's a for loop coming in here, so I don't need this I equals 0. I can put a for I equals 0. I want to run the loop while I is less than n data. Now I have to think, remember we need two pieces of data for one velocity. So our upper limit should be n data minus 1, not n data, right? Because we need the there's an I plus 1, okay. We'll look at that in a second and explain why that loop, and we want to increment I each time. So what are we going to calculate here? V. And I already have the calculations, these formulas right here, so let's just modify them. Okay, I'll just copy them up. Okay, so now it's HI plus 1 Ti and Ti plus 1, and this loop can be Ti plus 1. All right, okay. And that should complete the calculation of velocity. So there's our calculation of velocity, now completed, right? It's done the whole loop. We go to the loop, we I plus 1 at the very end, so I equals 0, right? I less than n data minus 1, there's the condition. And I plus plus each time doing the calculation. And the limit is n data minus 1. Because I plus 1, right? We'll run out of data. Okay. Oh, I admit one guest. Okay, sorry about that. Okay. Okay. Okay here, guys? Yes? No? No. Okay, great. Okay. Good. All right. Yes. Oops, right. Thank you very much. Okay. Great. Okay, let's continue on. Okay, thank you very much. I skipped a bracket. Sorry about that. Thank you for telling me. Okay, and where are we storing this in? This is being stored in TV brackets. We have to see what container we want, I. And this is going to be stored as V in the container V.I. Because obviously we could do that, but it would just keep throwing it away. So we want to store in each container. Okay. Okay, let's continue. Next thing we want to do is to calculate acceleration. Okay? Now, if we look at the acceleration window, acceleration is calculated the same as velocity, right? The structure is exactly the same. So it's going to loop except for the, okay? So let's just copy the loop. Okay, the limit is n data minus 2 because we lose another point. And the input is velocity, velocity, t velocity, t velocity, t velocity, t velocity. And we're calculating the acceleration and t acceleration. Okay, so there's the acceleration loop is now done. Okay, because it's just a repeat of this previous one. So we now have another for loop. And, okay, let's make sure everybody's up to here. Okay. Okay, let's move on and continue the final step, the printing. All right. Printing is another for loop, I equals 0. Okay, for, oops, Control Z, oops, C, 4, I equals theta, I and data minus 2. What do I want to do? I want to print everything. So I'll probably do, I don't think I can use my old fprintf I can't use here because it's too small, right? No use. Okay, so I might as well throw out all this other stuff here. It's not that use anymore. Get rid of it all. Okay, so let's start we need a for loop to do the print. Fprintf, standard out, out. Okay, we're definitely going to want it formatted, so let's just put %lf, comma %lf, comma %lf, comma %lf, comma %lf, and let's not have too many decimal points. 0.2, 0.2, 0.2, 0.2. I'm going to make it right across, sorry. Make it sort of wider for you. Okay, 0.2, 1, 2, 3, 4, 5, and 6. Okay, and then I'm going to want a carriage return after it, right? And a carriage return, so new line. And what are we going to print? Okay, H brackets I, comma T, hard brackets I, comma H brackets I, okay, then V brackets I, no control C, V hard brackets I, TV hard brackets I, A, oops, comma A hard brackets I, comma TA hard brackets I. Okay, so that should allow us to print up until n minus 2. Okay, now acceleration is only to n minus 2, but we have one more velocity, so I'm going to have to write another line here to take care of the endpoints. And one final line to get our final input piece of data. Okay, so that should basically complete the whole program. You can check your program. I don't change anything in the functions. Keep the functions all the same. Don't touch functions. Except I probably would like to get rid of this guy. Yeah, let's get rid of him. I don't want this. I don't want this printf. Okay. So I'll save it. Okay, please check. Make sure yours is okay, and then we'll try to compile it and run it. Okay. 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 Okay, let's check and make sure. Okay. We'll show the error. Okay. Okay, so I'm just going to compile it. GCC minus C minus wall G dot C, and I'll get a bunch of errors. Okay, great. All right, let's see what are my errors. The first one is on line 23. What is it not like? TA is undeclared. Okay, what have I done up here? Oh, I called it, oh, okay, it should be T, okay, TA, not AT. Okay, save that. Okay, hopefully solve that problem. What's my next error message? I'll recompile it. Okay, next error message is 5031. And it says format %LF expects matching argument. Okay, so it's pointing here and saying there's one argument, two argument, something's missing here. So let's go down. What's missing? 31, 1, 2, something's missing. Oh, because I've only got two arguments here. Okay, get rid of this. Okay. There, that's fixed too, hopefully. And now the program's okay. Okay, compile's okay. All right. Okay, so you guys will, you have to make sure your program also compiles. Okay, good, good, good. All right, good. Compile's good. Okay. All right. You can see what the error is, and it's okay. Okay, so then after that, GCC minus O G dot exe G dot O. Okay, now I should be able to run my program. For myself, I'll download this file, right click on mgd.csv and save link as mgdt. Oh, I already got it here, so I don't need to save it, but just save the link. Okay, so what is mgdt? Type mgdt.csv. It's this thing. It's the data points. So height and the time. Okay, terminated by -1. Okay, so just down, and then now I can use that as my input file. So for example, I can then write G. Let's take the input from mgdt.csv. Okay, and you can see the output. I can then send the output. Now, watch care, understand. So this allows me to get the input from this file. Now I'm going to send it to table.csv. Okay, so I'm sending it to another file. Nothing will appear on the screen. The result will be in table.csv. If I type table.csv, okay, I'll get a message here. Okay, sorry, it opened in the other screen. So it'll just open it. It'll just open the file in Excel. Your data file is already nicely in Excel. So you've created a file that can be read by Excel and opened by Microsoft Excel. Okay, so this will be what you want to do. So you can make sure you download this. You can then calculate the table and then just type table and Microsoft Excel will open it. And you can see all your data. Here's your acceleration. Actually, I don't like one problem. I should probably put in a title row, right? So maybe I want to modify my program a bit. But first of all, make sure this works okay. Just download the file. Yeah, don't bother checking every PDF. Just download the file. You already typed it in the other day, right? So all you want to do is just download this file. Save link as. No, you want to download the one in front. PC. Okay, now it's going to give you a new message. Now, oh. Okay, what's wrong? This is a T, and the use TA. Okay, so fix that T. Okay, good. And then you use it anywhere else. Okay, so there you go. What's its message? 35, 80 is not used. Okay? Why is 80 not used? 80 is used here. Oh, you're missing a loop. You got another loop here to velocity first. You need to one loop up here to velocity. You're missing that. Just make another loop. Copy. Okay, good. There, did that. Okay. Okay, try it again. Unexpected semi-load. Immediate line was not used. Expected declaration and we got to go to practice somewhere. These guys are together. Teams are missing another closing bracket here. Nobody matches this guy. This is back. Okay. Okay, I think most people finished. Okay. Okay, I think pretty well everybody's okay with. Let's walk our way through the code, and then we're going to take a break. Okay? All right. So we have modified this code, and your modified code looks something like this. It may not be exactly the same, but it's basically similar to this. At least this is what I did last year, and I think it's. Oh, I've got an extra line here telling what the columns are, and it also prints a few zeros, but it's similar to the previous year code. Okay, so let's walk through the code. We've run the code. Let's walk through it. Okay, main starts. Okay, you know the prototype at the beginning. Main starts. I declare a whole pile of arrays. Okay, all these arrays are occurred. 0, 1, 2, 3. These are the indexes. Index 0, 1, 2, 3, 4. Index 0, 1, 2, 3, 4. VT 0, X1, 2, 3, 4. So main has control of pointers. Each of the pointers is pointing to a whole, how many m elements? In this case, m equals 1, 2, 3, 4, 5. M equals 5 elements. Each of these pointers is pointing to a set of 5 variables, an array. We then next line creates 2 containers. One container and data, and I don't know what's inside it. And the other container I call K, and I put in -1. We then enter into our do loop. Our do loop, we enter unconditionally. So there's no conditions here. It doesn't check anything. It immediately enters into the do loop. So you know with this do while, the statement will be executed at least once. So its first thing it does is it increments K. So K is now incremented to 0. And then it calls our get Y and T. So we call the function, and the function returns 42.5 and 0. So it reads the first thing from our file. And we check. Is 0 greater than -10 to the -8? Repeat. Yes, it is. So we will repeat. Increment K. Get Y and T. This time 39.5, 0.78. Check. Is Y1 equals 0.78 greater than -10 to the -8? Yes, it is. Repeat. Increment K. K is now equal to 2. Get the values. All right. This time it read 33.5 and 1.36. 1.36 is greater than -10 to the -8. Repeat. Increment K. We're now up to 3. Next, we are going to try to read the file. Okay, I read -1. Okay, and that tells me, y of 2 equals -1 is less than -10 to the -8. Exit the loop. Yt of 3, sorry. Okay, it's 3. Sorry about that. Exit the loop. I exit the loop. I now set n data to 3. Okay, K is now set to be 0 again. K less than n data -1, K plus plus. So K set equal to 0. And I check. It's less than n data -1, which is 2. So I'm going to enter my loop. V of 0, I take the derivative using these 4 numbers. I then get the mean time, 0.39. I increment K. K equals 1. K is still less than 2, so I'm going to enter the loop. I called c dy dt. It gives me the derivative, and I store that in v brackets 1. I then store the time in vt hard brackets 1. I check my loop again. K is now equal to 2. K equals 2 equals n data minus 1. Exit loop. No more looping. Jump down to my next loop. I've got 2 velocities, so I'm going to be able to calculate 1 acceleration. So K is set equal to 0. K is equals 0 is less than n data minus 1, so enter the loop. AK, okay, calculates acceleration minus 9.56, calculates the mean time of these 2 times, 0.73. Checks increments K, checks K equals 1, n data equals minus 2 is 1, so exit the loop. And we now move into our fprintf loops. First of all, I print H, T, V, T, V, A, and TA. I then start my loop. First of all, I print my first row, check K, print the second row, check K, still K is now 2, so I can do my third row, and K is now no longer, K equals 3, and that equals 3, exit loop. So in this case, you can see I've got zeros here, and 0, 0, 0, 0 for the second point. So I just did a loop, but since I'd already stored 0 in my arrays, it had already been initialized to 0. I can recognize this is 0, and this is not a real no calculation was done here. Okay, so you've seen 2 different ways of doing this. Here, I initialized everything with 0 and just used a single loop. In the program I gave you earlier, I initialized nothing, but I made sure when I printed in a more complicated way. Okay? Which way you do is your own choice. Okay, so let's break now for about 10 minutes, and we'll come back in about 10 minutes. Okay? Break for 10 minutes. If you have any questions, please ask me or the TA. Thank you very much. Pardon? No. Probably someone was writing a test here.
I think I go to office and